Hi, I'm Joe James. In this video, we're going to cover logarithms. I'm going to teach you everything you need to know about logarithms, what a logarithm is, how to convert between logarithmic and exponential equations, and how to apply 7 different laws of logarithms. I'll walk through a bunch of different examples so you can see how to use those laws of logarithms to solve problems. And then at the end, we'll walk through several different sample problems so you can actually use the laws of logarithms to solve problems. Already familiar with a typical exponential equation. Looks like this. So 10 to the power of 2, or 10 squared, equals 100. So we could write that using variables as some base b raised to some exponent e is equal to some result r. So here 100 is a result of raising 10 to the power or exponent of 2. So b, e, and r. Now, if we want to rewrite this, we could rewrite exactly the same thing in logarithmic form. It would look like this. So log base 10 of 100 is equal to 2. So in this case, this 10 is the base. You see how this is the base? That's the number that we're raising to some power. What power are we raising it to? Well, we're raising it to this power, the 2. And so that exponent, or e, goes on the right-hand side of the equal sign. So log base 10 of 100 is equal to 2. That's the equivalent equation to 10 squared equals 100. In logarithmic form, it looks like this. Log base 10, 10 is the base, 2 is the exponent, and 100 is the result of raising 10 to that power of 2. So 10 to the 2 power equals 100. And in a generic form, it looks like log base b of r, that result, is equal to e, the exponent. So let's do a few practice problems rewriting these three in exponential form. We're given log form. Log base 3 of 81 is equal to 4. So 3 is the base. So we're going to say 3 raised to what power? Well, this 4 is the exponent, remember? So 3 to the 4th power is equal to 81. The 81 is the result. So 3 raised to the power 4 is equal to 81. These are equivalent statements. So the next one, log base 12 of 144 is equal to 2. That is equivalent to saying that this base 12 raised to the power 2 is equal to 144. So let's rewrite this as 12 raised to the power 2 equals 144. That's the result. 144 is the result. So log base 12 of 144 equals 2, or 12 to the 2 power equals 144, right? Those are equivalent. How about this one? Well, the base is 2, right? This little subscripted 2 is the base. So 2 raised to what power? Well, the power of 7. 2 to the power of 7. The 7 is the exponent on the right-hand side. And the 128 is the result, so that equals 128. So it's that easy to convert from logarithmic form to exponential form. Now we're going to try a few working the other direction, where we're given exponential form and we need to rewrite those in logarithmic form. Let's try that. So let's say 5 squared equals 25. So what is the base here? Well, the base is the number that we're raising to some exponent, right? So that would be 5 in this one. The exponent is the 2, and the result is 25. So to write this in logarithmic form, we're going to write log base 5. So we're going to subscript that 5, a small 5 subscripted, of 25. We write the result really big, okay, of 25. That's the result. Equals the exponent, right? What's the exponent? 2 equals 2. So log base 5 of 25 equals 2 is the same thing as saying 5 to the 2 power equals 25. So that's an equivalent equation. Okay, the next one. 36 to the 1/2 power equals 6. And we know, by the way, that if you watch the exponent video, 36 to the 1/2 is the same as the 36 square root of 36. But anyway, our exponent is 1/2, the result is 6, and the base is this here, 36, right? So let's see, log base 36. So we're going to subscript the 36. And then what? We write the result in big, right? Which the result here is 6. That's the result of taking 36 to the 1/2 power is 6. So log base 36 of 6 equals 1/2. And that's equivalent to saying 36 raised to the 1/2 power, that's the exponent, is equal to 6. Let's look at the next one. M raised to the n power equals k. All right. So let's see. Log, what's our base? M. M is the base, right? And then what is the result? Well, k is the result, isn't it? So we're going to put k here equals the exponent. We're going to write the exponent on the right side, and that's n. So log base m of k is equal to n. So that is a few examples of converting exponential format to logarithmic format. So what is a natural log? You'll hear this term natural log. What does that mean? Well, natural log is log base e, and e is a constant. E is Euler's number, or if you're from Europe, it's pronounced Euler's number. But he's a famous mathematician. He has his own constant called E, and E is equal to 2.71828 ... It goes on and on, like pi, right? It's a continuing, non-repeating decimal. So the natural log of x is the same thing as log base e of x. In other words, when you say natural log, you're implying that the base here is e. So when logs are used in industry, you'll typically see mathematicians using log base e, or natural log. That's most common. And engineers most often use log base 10. Programmers or computer scientists like to use log base 2 because everything is binary in computer code. So log base 2 is most common for programmers, but there you go. In industry, that's kind of more or less how people use logarithms. Now let's walk through some laws of logarithms. I'll show you some examples of each one of these so you can see how they apply. So let's see, the first one, log base n of 1 is equal to 0. Well, that is the same thing as saying n to the 0 power is equal to 1, right? N to the 0 power is equal to 1. So another example would be 15 to the 0 power is equal to 1. We could rewrite that as log base 15 of 1 equals 0. And anything to the 0 power is equal to 1. So you could convert this to a logarithmic equation as well. This is similar then to the 0 power rule of exponents. So that's the first law of logarithms. Log base anything of 1 is always going to be 0. The second law is, again, similar to the second law of exponents. Log base n of n is equal to 1. In other words, if you have the same base and the same result, then the exponent is always 1. And that's equivalent to saying, if you rewrite this, n to the 1 power is equal to n, or anything to the 1 power is equal to itself. So 26 to the 1 power is equal to 26, or log base 26 of 26 is equal to 1, right? So that's the second law. It really just states what we already know from the exponent laws, that anything raised to the 1 power is itself. And log n of n is always going to be equal to 1 as long as these two numbers are the same. Now the third law, log a to the x is equal to x log a. In other words, we can take that exponent and bump it out in front of the log if we want. So this is a pretty cool law, and it's really handy sometimes when you're solving logarithmic equations. So log of 10 to the third power is equal to 3 times log 10. And since log 10 is 1, that's equal to 3. Now, 8 log 12 is equal to log of 12 to the 8th power. In other words, you can move this 8 from out in front of the log into the exponent of the 12. So you can work this both ways. So that's a very handy law, and you'll probably use it frequently when you're solving logarithmic equations. Number 4, log base n of n to the x equals x. So if we think about this, if we take n, we want to rewrite this in exponential format, right? N to the x power equals n to the x, right? This is the result, this is the base, this is the exponent. So in other words, if we write log base 5 of 5 to the 2 equals 2, if we convert this to exponential format, we're saying 5 raised to the 2 power equals this result, which is 5 to the 2, right? So this one is pretty intuitive. Number 5, log base n of x plus log base n of y is equal to log base n of x times y. In other words, when adding logarithms of the same base, you can multiply those two results together. For example, log base 2 of 4 plus log base 2 of 8 is equal to log base 2 of 4 times 8, or log base 2 of 32. And if you actually wanted to solve this, log base 2 of 4, what's that? 2 to what power equals 4? Well, 2 squared equals 4, so we can put a 2 there. This is equal to 2, right? Plus log base 2 of 8. Well, 2 to what power equals 8? 2 to the third power equals 8. So we could put a 3 in place of this because this equals 3. So 2 plus 3 is equal to 5. In other words, 2 plus 3 equals 5. Log base 2 of 4 times log base 2 of 8 is equal to log base 2 of 32. So 2 to the 5th power is equal to 32. So I hope that's not too confusing, but yes, you can multiply those two results together if you have the same base. It's a pretty cool law. Then the next law, number 6, log base n of x minus log base n of y. Well, you can divide those two results. It's very similar to number 5, except it's for subtraction / division instead of addition / multiplication. So in our example here, log base 3 of 27 minus log base 3 of 9, you can see we have the same base, log base 3. What do we do? Well, we divide those two results. 27 divided by 9, we get 3 as a result. So 3 to what power is equal to 3? 1, right? 1, yeah. So log base 3 of 27 is 3 to the 3 power. Log base 3 of 9 is 3 to the 2 power equals 9. So this is the same as saying 3 minus 2, isn't it? And 3 minus 2, well, the result we get is log base 3 of 3, which is equal to 1. Anyway, if this example is a little bit too confusing for you, you can always just refer back to the laws here, which I think you'll find helpful. And you just got to figure out how to apply those laws to solve problems. The last one, number 7 here, is really critical when you're trying to solve logs in a calculator, because you only have 2 buttons in your calculator. You have a natural log button on the calculator, and you have a log button. And the implied base when you just see log is base 10. That's the implicit base. That's the default base for a logarithm. It's always base 10. So this log button is going to use a base 10 to calculate the log. Or you can use the natural log, which is log base e, which frankly I don't use a whole lot. But so how do we calculate log base 8 of 30 on a calculator? Well, there's no log base 8 button, and there's no way to put in log base 8 in a calculator. So what we have to do is apply rule number 7 here before we can actually solve for this on our calculator. How do we do that? Well, log base a of x is equal to log base b of x over log base b of a. In other words, doesn't matter, this can be any base we want, but log of x over log of a. And what we typically do is we use a base 10, which is the default for log, right? So in other words, log base 8 of 30 is equal to log 30 over log 8. So log big number or log result divided by log base, right? So we can put this into the calculator to find out the answer to this. In order to calculate this, you have to put it in a calculator as log 30 divided by log 8. And it's going to use a base 10 here and a base 10 here to calculate it. That's fine. So this change of base converts it from a base A to a base 10 for using on the calculator, which is pretty essential for calculating a log. Same here. Second example, log base 5 of 14. Well, we can't put that into the calculator like that. Instead, what we put in the calculator is log 14 divided by log 5. And the calculator is going to use a base 10 here and a base 10 here to calculate that, and it's going to give us the right answer. So this change of base is pretty handy, especially when you're using a calculator. Now let's solve a few practice problems using some of these laws that we just learned. So let's see, our first one is log base 8 of 1. Well, what we're asking here essentially is what? 8 to what power is equal to 1? 8 to what power is equal to 1? 8 to the 0 power is equal to 1, right? So this one is just 0. Raising 8 to the 0 power would give us a result of 1. This one says log base 5 of 5 to the x equals what? Well, 5 to what power equals 5 to the x? 5 to what power equals 5 to the x? 5 to the x power equals 5 to the x. That's an x. So the answer to this one is just x, right? 5 raised to the x power equals 5 to the x. And this was one of our rules too, so this is pretty simple to apply. Log base 4 of 4. Okay, now there's a rule for this, one of our rules, but I don't remember it. But anyway, I can just rephrase this as 4 to what power is equal to 4? Oh, since I phrase it like that, it's 1, isn't it? Anything to the 1 power is equal to itself. So 4 to the 1 power is equal to 4. So the answer to log base 4 of 4 is 1. Log of 5 plus log of 7 equals what? Well, remember the product rule here for logs. We're going to multiply these together. So this is equal to log of 35, right? 5 times 7 is 35. So log of 35. And let's see, this next one here, log of a to the 3 is equal to what times log of a? Well, remember the rule where we can take this exponent and just bump it out in front if we want to. So we can rewrite this question mark here as a 3. So that's equal to 3 log a. All right, let's do a few more practice problems. Log base what of 27 is equal to 3? So if we rephrase this, what raised to the 3 power equals 27? Let's see, what number cubed equals 27? 3 times 3 times 3, right? 3 times 3 is 9, times 3 is 27. So this question mark is going to equal 3. So question mark here is 3. Log base 3 of 27 is equal to 3. In other words, 3 cubed equals 27. Okay, what number raised to the 4th power equals 625? In other words, n times n times n times n equals 625. What is n? The 4th root of 625. Let's see. 5 times 5 times 5 times 5, right? 5 times 5 is 25, times 5 is 125, times 5 is 625. So here the question mark is 5, because we know that 5 times itself 4 times is going to give us a product of 625. Okay, log base 6 of 216 equals what? In other words, what exponent do we need to raise this base 6 to get to 216? Well, let's see, 6 squared is 36, so that's 2, and then times 6 again would give us 216. So this exponent is 3, so that's just 3. 6 to the third power equals 216, right? 7 raised to the 2 power equals what? Here the question mark is in the result space. So 7 squared is 49. So those are a few sample problems using logarithms. You should be able to figure out each one of these depending on where the question mark is. These are not too complicated. That wraps up this video on logarithms. I hope this was helpful for you. If so, please click like and subscribe to my channel. I'm Joe James. Thanks for watching.